Hi everyone, and welcome back to this series about Git Merge and Rebase. In the previous video, we covered Git Diff. We learned what a diff is, what a patch is, the differences between them, and we closely looked at the output of Git Diff. We learned how a patch is constructed, and then we also discussed applying patches. Now, before we start with this video, I want to say big thank you to Pallavi Ghosh, and I hope I'm pronouncing the name correctly. Thank you for being the first supporter to buy me a coffee using the Buy Me a Coffee link down in the description below. Your support really warms my heart, and that applies also to all of you who leave comments and feedback down there. It really boosts my motivation to create more content. So thank you, Pallavi, and thank you to all of you. Okay, so for this video, we're going to focus on Git Merge, and we'll start by asking ourselves, what is a merge?
Merging is the process of combining the recent changes from several branches into a single new commit that will be on all of those branches. In a way, merging is the complement of branching in version control. A branch allows you to work simultaneously with others on a particular set of files, whereas a merge allows you to later combine separate work on branches that diverged earlier from a common ancestor commit. Okay. Let's take this bit by bit. Let's remind ourselves what a branch is in Git. As we covered in a previous video, a branch is just a name pointing to a single commit. When we think about commits as being on a specific branch, they're actually reachable through the parent chain from the commit that the branch is pointing to. That is, if we consider this commit graph, we see that the branch feature 1 here, which points to a commit with a SHA value of BA0D2. Of course, as in other videos, I'll only write the first 5 digits of the SHA1 value, just so it's shorter to relate to that value. So we can see that commit 5489D is also on this branch, as it is the parent commit of BA0D2. So if we start from the pointer of feature 1, we get to BA0D2, which then points to 5489D. So when we perform merge with Git, we merge commits. Almost always, we merge two commits by referring to them with the branch names that point to them. And thus we say we merge branches, though under the hood, we actually merge commits. Okay, so let's say I have this simple repository here with a branch called main and a few commits with the commit messages of commit 1, commit 2, and commit 3. Just like so. Pretty simple. Now I'm going to create a feature branch. So I'll use git branch new feature. And I'm going to switch head to point to this branch. So now I have head pointing to new feature, which points to commit 3, and main also points to commit 3. As a reminder, I could have also written git checkout -b new feature, which would do both the branching and the checkout for me. To clarify, what we now have is two named pointers, one called main and the other called new feature, and they both simply point to commit 3. Again, if you need a reminder about branches and how they're implemented under the hood, please check out the previous video on the subject.
Yes, check out. Pun intended.
Now, on my new feature branch, let me implement a new feature by adding a simple function to my source file. So this file currently looks like this. Pretty simple. And I'll now edit it to include a new function. So let me write here a new function that prints new feature. So thankfully, this is not a programming tutorial, so this function is legit. Next, we'll stage and commit this change. So let's git add code.py to stage it and commit 4. Cool. So now let's consider our history. We now have head pointing to a new feature, which points to commit 4, which points to commit 3, where also main points to. So instead of looking at it like that, I'm going to use another command So git lol is not a command in Git, but rather an alias for Git that I created to show the history in a more readable way than git log would show without additional switches. I'll share it with you in the comments below if you're interested. So looking at the history, we basically have the branch new feature now pointing to commit 4, which points to its parent, commit 3. The branch main is also pointing to commit 3. Okay, so now say we would like to merge our new feature. That is, merge these two branches, main and new feature. Or in Git's lingo, merge new feature into main. Actually, this means we would want to merge commit 4 and commit 3. This is pretty trivial, as after all, if we look at the history again, commit 3 is an ancestor of commit 4. So let us check out the main branch. And now we can perform the merge. So I'll use Git Merge new branch, which will merge new branch into main. Oops, that was a typo. It's, of course, new feature. And as we can see here, Git performed what is called a fast forward. So as new feature never really diverged from main, Git could just perform a fast forward merge. So what happened? Let's look at the history again. Even though we used Git Merge, there was no actual merging here. Actually, Git did something very simple. Reset the main branch to point to the same commit as the branch new feature. Now, let's say we don't want that to happen, but rather we want Git to actually perform a merge per se. In this case, we could either change Git's configuration or run the merge command with the noff flag. So let's undo the last commit. If this way of using reset is not clear to you, feel free to check out the relevant video where we covered Git reset in depth. It is not crucial for this introduction of merge, though. So for now, it's important to understand that I basically undid the merge operation. Just to clarify, now if we check out new feature again, the history would look just like before the merge. Cool. So now let us perform the merge with the no fast forward flag. So I'll check out main and I'll merge new feature with no fast forward. Now I get this prompt for a commit message for the commit. So let's just go with the default here. And now if we look at the history, we can see that Git actually created a new commit, a merge commit. And now we can see that it's pretty interesting the way Git lol shows it. We can see a visual diverging. So the new commit for F90A62 in this case has two parents, commit 4, which was the commit that new feature pointed to when we ran Git merge, and also points to now, and commit 3, which was the commit that main pointed to. So a merge commit has two parents, the two commits that it merged. The merge commit actually shows us the concept of merge quite well. We take two commits, usually pointed to by two different branches, and merge them together. So now, as we started the process from main, we are still on main, that is head points to main, and the history from new feature has been merged into this branch. Since we started with main, then commit 3, which main pointed to, is the first parent of our merge commit, whereas commit 4, which we merged into main, is the second parent of the merge commit. So if I use git log and I request only 1, so we can see that the SHA-1 of commit 3 is the first parent, and the SHA-1 of commit 4 is listed second. Notice that we started on main when it pointed to commit 3, And Git went quite a long way for us. It changed the working tree, the index, and also head, and created a new commit for us. Now, this was a super simple case, where the branches we merged did not diverge at all. By the way, we can use Git Merge to merge more than 2 commits, but rather any number of commits. This is rarely done, and I don't see a good reason to elaborate on it here. Another way to think of Git Merge is of joining 2 or more development histories together. That is, when you merge, you incorporate changes from the named commits since the time their histories diverged from the current branch into the current branch. I use the term branch here, but I'm stressing this out. Again, we are actually merging commits. Let's look at a more advanced case, which is probably the most common case where we use Git merge explicitly, where we need to merge branches that did diverge from one another. So say we continue now with this repo, and let's say we have 2 people working on this repo now, John and Paul. So John created a branch. And John has written a new song in a new file. Well, I believe John Lennon didn't really write in Markdown format or used Git for that matter, but let's do it here. So let's add this file and commit it. So while John was working on this song, Paul was also writing on another branch. So Paul had started from main and created his own branch. And Paul wrote his song into another file. Paul also staged and committed it, as obviously great artists usually do. So now our history looks like that. So this way we can actually see also the history that is not currently reachable. So we can see here that Paul branch is diverged from main and John branch is also branched from main. So John is happy with his branch, that is his song. So he decides to merge it to the main branch. So check out main and Git merge John branch. Actually, this is a fast forward merge, as we have learned before. Now, Paul also wants to merge his branch into main, but now a fast forward merge is no longer relevant. There are 2 different histories here of main and of Paul branch. It's not that Paul branch only adds commits on top of main branch or vice versa. So what do? Now things get interesting. So first, let's let Git do the hard work for us and then understand what's actually happening under the hood. So we can simply run git merge whole branch. And again, we're prompted to provide a commit message for the merge commit. Let's consider the history now. So what we have here is a new commit with 2 parents, commit 5 and commit 6. That is what used to be Paul branch and still is, and what used to be John branch as still is. Now, if we look at the working there, we'll see that both John's song as well as Paul's song are here. So we can see both of the files. So nice, Git really did merge the changes for us. But how does that happen? Let us undo this last commit. And now let's understand what's really happening under the hood. What Git does here is called the 3-way merge. In outlining the process of a three-way merge, I'll use the term branch for simplicity, but we should remember this could also be two commits that are not referenced by a branch. In a high level, the process includes these stages. First, Git locates the common ancestor of the two branches, that is, the common commit from which the merging branches most recently diverged. Technically, this is usually the first commit that is reachable from both branches. This commit is then called the merge base. Second, Git calculates two diffs, one diff from the merge base to the first branch, and another diff from the merge base to the second branch. Git generates patches based on those diffs. Third, Git applies both patches to the merge base using a three-way merge algorithm. The result is the state of the new merge commit. So back to our example. Let's look at this process and apply it manually ourselves. On the first step, Git looks from both branches, main and pull branch, and traverses the history to find the first commit that is reachable from both. So in this case, it would be which commit? Well, if we're not sure, we can actually always ask Git to tell us. So to do that, we can just use Git Merge Base main pull branch. And the result is this SHA-1 value. And if we look at the history again, we can see that this is indeed the SHA-1 value of the merge commit, as this is indeed the first commit that is reachable both by pull branch and the main branch. By the way, this is the most common and simple case where we have a single obvious choice for the merge base. In more complicated cases, there may be multiple possibilities for a merge base, but this is a topic for yet another video. So in the second step, Git calculates the diffs. So it first calculates the difference between the merge base and commit 5. So let's do that. We'll write down the commit chas. Let's select the commit cha of commit 5. And we can use git diff or F90A62. That's probably enough to commit 5. And we get this output. If you don't feel comfortable with the output of git diff, please watch the previous video where we described it in detail. So here we can see a diff that shows that we're adding a new file. That's why we get from dev null to a file called Lucy in the Sky with Diamonds that includes 40 lines, these lines here. So I would actually like to store that into a file. So let's take this output and write it into John branch diff.patch. Cool. Then Git goes on to calculate the diff between the merge base and commit 6. So let's copy the SHA-1 of commit 6. And let's see the diff between the merge base and this commit. So indeed, in this commit, we introduced Penny Lane. So we're going to store this as pull branch diff.patch. Sweet. Now Git applies those patches on the merge base. First, I'd like to try that out directly, just applying the patches. This is not what Git really does under the hood, but it will help us gain a better understanding as to why Git actually needs to do something different, at least in some cases. So let's start by simply applying the patches. Git apply. And of course, we need to check out to the merge commit first. So let's do that. So we've applied John branch diff.patch. Notice that for now, there is no merge commit. Git apply updated the working dir as well as the index as we use the -- index switch. So we can see here that there is a file to be committed as it is staged. So now John's new song is incorporated into the index. Let's apply the other patch. So git apply index pull branch diff dot patch. And now the index contains changes from both branches. Now it's time to commit our merge commit. Since the porcelain command git commit always generates a commit with a single parent, we would need the underlying plumbing command git commit tree. If you need a reminder about porcelain versus plumbing commands, check out the video where we explain these terms and created an entire repository from scratch. Let us remind ourselves that every git commit object points to a single tree. So we need to record the contents of the index in a tree first. So for that, we can use git write tree. Now we have the SHA-1 value of the tree, and we can create a commit using git commit tree. So I'm going to use git commit tree, provide the SHA-1 of this tree of the index, and we'll use -p for a parent, and I'm going to provide the commit SHA of commit 5. Oh, we had it before, so let's take it from the history here. Use for commit 5 and -p. The SHA of commit 6. Cool, and this is our merge commit. Oh, sorry, I had a typo there. It's 1783A9. Great, so now we've created a commit object. Recall that Git Merge also changes head to point to the new merge commit. So we can just simply do the same. Use git reset hard and change it to the new commit we've just created. So head is now at the merge commit. So if we look at the history now, we will see that we've created a new commit, a merge commit, with two parents. One is Paul's branch and the other is John's branch. Basically, this is the same result as the merge done by Git, with the exception of the timestamp and thus the SHA-1 value, of course. So we get to merge both the contents of the commits, that is the state of the files, and also the history of those commits by creating a merge commit that points to both histories. In this simple case, we could actually just apply the patches using git apply, and everything worked quite well. So to quickly recap on a three-way merge, Git first locates the merge base, the common ancestor of the two branches, that is the first commit that is reachable from both branches. In this case, it was the previous merge branch of new feature into main for F90A62. Second, Git calculates two diffs, one diff from the merge base to the first branch, and another diff from the merge base to the second branch. In this case, it was to commit 5 and commit 6, respectively. Third, Git applies both patches to the merge base using a three-way merge algorithm. Now, we haven't explained the three-way merge yet, but we will elaborate on it later. The result is the state of this new merge commit. We can also understand why it's called a three-way merge. Git merges three different states, that of the first branch, that of the second branch, and their common ancestor. In our previous example, main, Paul branch, and commit for F90A62. This is unlike, say, the fast-forward examples we saw before. This is actually a case of a two-way merge, as Git only compares two states, for example, where main pointed to and where John branch pointed to. But still, this was a simple case of a three-way merge. John and Paul created different songs, so each of them touched a different file. It was pretty straightforward to execute the merge. What about more interesting cases? So let's first move the main branch to point to the current head. So I'm going to check out main. I'm going to reset it to point to this newly created commit. Cool. So again, we have this history, but now head points to main, which points to the newly created merge commit. So now let's consider a more advanced case. Let's say John started a new song on main branch. Cool. So let's save stage and commit this one. Okay, so let's get some space here and now Paul branches. And he edits the song and adds a new verse right here in the middle. So I'm pretty sure that in the original version of the song, we don't have the title Paul's verse. I'll edit here just for simplicity. So Paul saves the file and stages and commits it. So now John also branches out from main. So let's get back to main and check out a new branch. And John edits the file. And of course, the file wouldn't have the changes included by Paul, right? Because those changes are only on Paul's branch. And John adds 2 last lines here and stages the changes and commits them. Great. So both Paul and John modified the same file on different branches. Will we be successful in merging them? Say now we don't go through main, but John will try to merge Paul's new branch into his branch. So git merge Paul branch 2. And oh, wait, why would we let Git do the hard work for us? We're trying to understand the process here. So first, Git needs to find the merge base. Can you see which commit that would be? So correct, it would be the last commit on main branch, that is commit 7. This is the last commit where the 2 diverged. We can verify that by using Git Merge Base, and this time we want the merge base of John branch 2 and Paul branch 2. And indeed, we see this is the SHA-1 value of commit 7. Great. Now Git should compute the diffs and generate the patches. So let's observe those patches. We'll use git diff from main. This is commit 7 to Paul branch 2. So indeed, this patch adds Paul's verse. Will applying this patch on main work? Let's check out main. Will applying this patch work? Well, no problem. We have all the context lines here in place, so Git knows exactly that it needs to insert these lines right in place. So let's store the diff to Paul branch 2.patch. Let's apply, change the index accordingly. Paul branch 2.patch. Cool. And this worked, no problem at all. So now let's compute the diff between John's new branch and the merge base. So git diff main and John branch 2. And here we can see that we're adding the 2 lines at the end. Now, the line numbers are no longer up to date, right? It starts from 21 here as the patch had been created before we made those changes by introducing Paul's changes. So will applying this diff work? Well, indeed, yes. So even though the line numbers have changed on the current version of the file, thanks to the context lines, we're able to locate where we need to add these 2 new lines. So let's save this patch and apply it. Awesome. So let's look at the result file. And exactly as we wanted, we have John's first verse, we have Paul's verse, and we have again John's verse with the last additions. Exactly what we wanted. So we can now create the tree and the relevant commit as we did before. So let's use git write tree to write the contents of the index into a tree object. Now let's commit this tree. With two parents. One is a parent, Paul branch 2, and also John branch 2. And let's have a commit message. I'm sorry about that. I hit enter. So let's use it again. Git commit tree and provide the parents, Paul branch 2 and John branch 2. Merging new changes. And now we've created the new commit. So see how I use the branches names here? After all, they're just pointers to the commits we want. Cool. Let's look at the log from our new commit. And of course, we haven't changed head, so this still shows us the previous commit. So if we really want the new commit, we could either reset head to point to it or simply use git log. And let's actually see the history from 7949960. Cool. So we can see that we have the commit pointing to the two parent commits. It would even be better to use git lol here. Cool. So we can actually see the history now with this newly created commit pointing to both John branch 2 and Paul branch 2 as its parents. Exactly what we wanted. Now let's see what happens if we let Git perform the job for us. As we haven't moved head, so we can simply git checkout John branch 2 as before the merge. And now we can just use git merge Paul branch 2. And we're prompted for a commit message. So let's go with the default. And let's observe the resulting history. Well, this looks quite familiar with one change. So John branch 2 now points to the newly created commit, as Git also takes the trouble for this additional stage of moving head or whatever head is pointing to point to the newly created commit. We can also observe the file. Indeed, it includes changes from both branches. Beautiful, just like we did ourselves. But this was still quite simple. John and Paul worked on the same file, but on very different parts. If we wanted, we could actually also directly apply Paul's changes to John's branch. If we go back to John's branch before the merge, so let's undo the merge operation. And now we can basically just apply to the state the changes from Paul branch 2. This works. So we get the same result. As you can see, we have Paul's verse on top of John's branch. So this isn't always the case, but that's enough for this video. We'll handle more complicated cases in the next video. So to summarize, in this video, we learned about Git Merge. We said that merging is a process of combining the recent changes from several branches into a single new commit that is on all of those branches. We explained that merging is the complement of branching in version control. That is, a branch allows you to work simultaneously with others on a particular set of files, whereas a merge allows you to later combine separate work on branches that diverged earlier from a common ancestor commit. We considered a simple fast-forward merge that is possible in case one branch diverged from the other branch we're merging and just added commits on top of it. We then considered three-way merges and explained the three-stage process. First, Git locates the merge base. Technically, this is actually the first commit that is reachable from both branches. Second, Git calculates two diffs, one diff from the merge base to the first branch, and another diff from the merge base to the second branch. Git generates patches based on those diffs. Third and last, Git applies both patches to the merge base using a three-way merge algorithm, which we haven't yet covered in detail. The result is the state of the new merge commit. As we've seen, this process is quite straightforward on simple cases, but what happens when the two branches include changes on the same files and on the same locations? That's where merge conflicts occur. We'll devote the next video to merge conflicts, what they are, when and how Git can automatically resolve them on some cases, and what to do on cases where Git needs our help. So in the video after that, we'll explore Git Rebase.
In the meantime, I hope you've learned some new things and deepened your knowledge about Git. As always, I'm super happy to receive your feedback, comments, requests, or questions down in the comment section below, so please go ahead and leave them, and I'll see you all next time.